I'm going to show here how we can start with two reactants that are solutions and predict what the products are and then determine if those products are going to form a precipitate, which is just a solid substance. So these would be called precipitation reactions. Precipitation reactions are a type of exchange reaction, which is a broader category that we'll talk more about. But precipitation reactions are when we start with two solutions and we produce a solid. So the example we have here is a sodium phosphate solution react with lead nitrate solution. What precipitate, if any, will form? To answer this question, we first need to identify the two reactants. So that's our sodium phosphate and our lead nitrate. And then we want to predict our products. So I'm going to write these out first. So sodium has a 1 positive charge, phosphate is 3 negative. So I'm going to write that as Na, phosphate is PO4. If I flip those charges, the 3 goes with that sodium. Over here we have lead is 2 positive, nitrate is 1 negative. So we have our Pb. Nitrate is NO3, and then I need 2 of those. So these are my two reactants. They're both going to be aqueous, so we can check our solubility chart. So sodium is on the top of our list, and then nitrate is second. So anything with sodium in it or nitrate in it is going to be soluble. So we want to determine, though, from these two reactants, if a product is going to form a solid or be insoluble in water. So because this is something called an exchange reaction, we're going to just take these two reactants and predict the products based on exchanging cations and anions. So in the sodium phosphate, my cation is sodium. In my second reactant, the anion is nitrate. So I'm going to take the cation from the first reactant, combine it with the anion from the second, and then we're going to take the cation from the second and combine it with the anion from the first. And these will be our two products. So when we do this, it's important to go back to the original ions, right? So I don't want to do this. So I'm going to write this, but then I'll erase it in a sec. I don't want to just do this Na3 and then do NO3 too. So this is not a balanced neutral compound, and the reason is because sodium has a 1 positive charge. Remember, we said this already up here, and nitrate has a 1 negative. So I just need 1 sodium to balance 1 nitrate. So we don't want to just copy directly from what our reactants were. We want to go back to how do we balance those ions together. So this would be sodium is Na, nitrate is NO3, and since they're each just have that 1 charge, we just need 1 of each. Then we'll look at the other 2 we're going to pair together. So our lead was a 2 positive and our phosphate is a 3 negative. So when I write these out again, I have lead, we have the phosphate, and then I'm going to flip those charges. So the 3 goes with the lead and the 2 goes with my phosphate. So we've just taken our exchange reaction. So I have my two reactants that were provided to us. We come up with the products by taking the cation from the first, combining with the anion from the second. That's our first product. And then our second product is cation from the second, anion from the first, and that would be our second product. To actually answer the question that was provided, what precipitate, if any, will form, we need to check each of our products and using our solubility chart to determine if either of those is going to be to form a solid or be insoluble in water. So if you check your sodium nitrate, again, you'll find anything with sodium or nitrate in it is going to be aqueous. So this is not going to be a solid. I'll go ahead and label it as aqueous. If you look at the lead phosphate, the phosphate is going to show up on that bottom half of the chart in the insoluble section. So that is going to form a solid. Because that's going to form a solid, that is our precipitate. So the actual answer to this question would be A, that lead 2 phosphate would form the precipitate from these two reactants. So we want to go beyond this. I'm going to use this as a setup to talk about the next thing we're going to work with precipitation reactions, and that is to come up with a net ionic equation. So if I'm given two reactants, how do I come up with what's called a net ionic equation? And I'm going to erase Actually, let me get rid of this here. This equation that we have written here, this is a molecular equation. So we're going to introduce three different types of equations or reactions. This is going to be what's called the molecular equation. And then we're going to define a complete ionic equation and a net ionic equation. So this first one is molecular equation. And the molecular equation is just kind of giving you the overall picture of things. This particular one is not balanced. So to balance this, I would need to put I'll go ahead and balance this real quick. Put a 6 here and then a 2 here, and then I think we'd be in good shape. So when you're giving a molecular equation or you're asked for a molecular equation, it should have all of the information, all of the substances, and it should be balanced. Our next equation that we're going to do is called a complete ionic equation. And a complete ionic equation is going to give us a little bit more information, and it's useful particularly when we're working with solutions. So a complete ionic equation is going to take each of our substances that's aqueous and we're going to dissociate them. So in this case, we're going to look at that sodium phosphate here. And if it's aqueous, which it is, I'm going to represent it in this next equation as ions. So I'm going to say this sodium phosphate is made up of the sodium ions and the phosphate ions. And so I'm just going to write those, I'm going to break those down. I'm not going to worry about how many of each I have. You can do that if you want to. You can keep track of the coefficients and the subscripts to say that you have 6 sodium and you have 2 phosphates, but it's really not important in the complete ionic that it's balanced. What is important are the pieces, that we have pieces of sodium ion, phosphate ion, and so on. So I'll kind of show why that is true in the next step. So our next one, we have lead nitrate. Lead nitrate, it is aqueous, so I'm going to also break it up. This is composed of lead ions and nitrate. Then we go to the next one. So I have sodium nitrate. It's also aqueous, so I can split those up. I'm dissociating those. And then this last one is a solid. So I'm not going to dissociate these. We're going to leave this together as a solid. Okay, so the purpose of doing this is really to show kind of what you actually would see in the form of particles in this solution. So if I make like a little beaker and we have the left side would be my reactant and the right side would be my products, and I think about what's actually in there kind of floating around. So on the reactant side, this would be product, we have some sodium ions, we have some phosphate ions, we have some lead, and we have some nitrate ions. Then on the product side, or after the reaction happens, I still have those sodium, I have some nitrate, and then I would have this lead phosphate down at the bottom, right? And if thinking about particles, this side I have 4 particles, here I have only 3 types of particles because that lead phosphate is together. So the reason that I've drawn these this way is to help kind of visualize what's happening. Remember, for a reaction to be taking place, particles have to change. And in this case, we have several particles that have not changed. So we have the sodium here and the nitrate here, and then I still have sodium and I still have nitrate on the other side. So those particles are exactly the same before and after the reaction. So we have a special name for these. These are called spectator ions. So that's a term that you want to know. So spectator ions are ions that are present, but not actually participating in a reaction. So in the complete ionic equation, again, the reason that we don't need to balance, we just need to write out each of the pieces, is because I don't care how many are in there. I just want to know, did they change from beginning to end? So once you have your complete ionic, like we have here, then we just want to take each piece and check, do I have it on both sides? So I've got here sodium, and here I have sodium. If it's exactly the same form on both sides, we get rid of it. Here I have phosphate. I do have phosphate here in this compound, but it's not just an ion, so I don't cross it out. Same thing with my lead. I do have lead here, but it's not an ion, so I can't get rid of it. Here I have nitrate and nitrate, same form, so I can get rid of those. Then we're going to write our final equation. Whatever is left in that complete ionic equation gets written at the bottom. So I have a phosphate, we have lead, and then on the product side, we have our lead phosphate. And that's a solid. This last piece, this is what we call our net ionic equation. And this is usually our goal. So often your problems will say, given these two reactants, what is the net ionic equation? So in that case, we're looking for this last piece here. So in a net ionic equation, I want to emphasize there are three things you want to always make sure that you remember to do. So first one is does need to be balanced. I said the complete ionic doesn't need to be balanced, but the net ionic equation does need to be balanced. Second thing, charges on ions. So any ion needs to have charges in it. We don't put the charges, that doesn't mean to put the charges in the compound, but over here where you have ions, those need to have charges. And then we need to have all the states. So you should always include the states. Ions are always aqueous. So if I go back into my net ionic equation and just make sure I did each of these things. So balance, I need to balance it. So I need 3 of these and I need 2 of those. I do have my charges on my ions already. And then states, we have our solid here. My ions are always going to be aqueous. So this is a really common problem or question that you'll see. You'll see these on your exams. You'll be given 2 reactants. Here we have sodium phosphate and lead nitrate, and you might be asked what is the net ionic equation from the reaction between these 2 things. First, you would need to write your molecular equation. If it specifically asks for molecular equation, you do want to make sure to balance it. Then you have this middle one. This is the complete ionic equation. Complete ionic equation does not need to be balanced. And the complete ionic equation is optional. So usually I will ask just for the net ionic and molecular. It's helpful to get to the net ionic, but it is not required. And then in the net ionic equation, make sure you have these 3 things. You balance it, you have your charges, and include